All right. Hello, everyone. Thank you for joining us today. The time is 9:01 a.m. Pacific time. So we're just going to give people, a couple minutes to get into the stream, and then we're going to kick it off. Um, right now, I've got this rotating series of slides you can take a look at. There's a bunch of QR codes for you. You can go scan it if you're looking for a job or if you are interested in other events or things like that. Good morning. Yes, good morning, everyone. And as we typically do at the beginning of all of our events, I would love to know a little bit about where you guys are coming from. Rob, it's good to see you. I know you are coming from Seattle. Uh, but if you're not Rob, I'd love to know where you're coming from. And we'll get started in just a minute or so. All right. It looks like it is 9:02, and we've got quite a few people in the stream now. So I'm going to introduce our next speaker, our speaker today. So today we have a workshop from Shuveb from Unstract, and he's going to be talking about his experiences and what he's learned doing real-world data prep for LLM applications. And he's also going to walk us through some workshop code. So Shuveb, welcome to the stage. I'm going to let you, introduce yourself and tell us about what you're going to talk to us about today.
Absolutely. Thank you, Jen. Super happy to be here. I'm just gonna start my slides. I have a introduction of myself in there, so it's probably easy. I'm just gonna probably do that and then go from there. Let me see if I can share my screen. I hope you folks are able to see this.
I think yes.
All good, Jen?
Yes, we can see this.
Awesome. So this is about me. I'm a co-founder and CEO of Unstract, a startup solving data extraction problems around structured data. Mainly, we use large language models to be able to achieve that. I'm a typical garden variety nerd. Been mainly programming Linux or systems since '98 or so, and been building things mainly around startups. Right, either I work for startups or I built my own startups, things like that. Right. I split my time between India and the US. So why am I the right guy to have kind of give such a talk on on data extraction problems with PDFs, right? So as a co-founder of Unstract, right, we currently process about 5 million pages a month. So you can imagine we've hit a lot of corner cases with PDFs, right? So we see a lot of problems with them, and we've built a lot of technology to kind of solve a bunch of problems. But I don't want this talk to be like a sales talk, for Unstruct or anything. I want to share all kinds of problems that we have seen with PDFs, and I also want to bring up the code editor and show you some code with regards to how do we pull raw text out of PDFs. But then there's a bunch of challenges. We'll see what those challenges are. But also we will look at things like different libraries and services out there, and we'll also explore some of the limits of these libraries, right? And where they stop working, things like that, right? So that's what we'll spend our time on. And but it's a very interesting space that we have in front of us. Just before we can go look at the code or look at all the libraries, let's take a look at some of the challenges that we'll see, right? First of all, it's a huge challenge, right? Any industry, especially regulated industries like healthcare, retail, financial services, whenever they interface with the outside world, there's unstructured data. There's no doubt about that, right? And typically this data is usually PDFs, all kinds of PDFs, regular PDFs, forms, and different sorts of scanned documents and all that, right? And let's say a small amount of problems are solved by the current technology that we have, there's a huge amount of expansion that we can do using large language models, right? So the current technology that we have usually uses computer vision and machine learning to solve some problems, but I think we can definitely expand this using large language models now. Even with large language models, there are some problems that we are not able to solve with the current state of the art. But I believe that with vision models, we can address a larger market as well, right? So I want to just say that this is a humongous opportunity, almost unlimited TAM, right? So a lot of startups, you can see them trying to solve a bunch of problems around in this particular space, right? And even very conservative estimates say that this market is growing at around 30 to 40% per year, right? And if you take, for example, any horizontal use case of large language model, which is being monetized right now, right? People talk about large language models quite a bit, and they say that, oh, we're using them here, we're using them there. But take a step back and think about which of those horizontal use cases are actually monetizable today as we speak, right? Those are actually very, very few, right? And I think the number one use case for large language models is really in Q&A bots and enterprise search, which is a good thing because then you'll need a bunch of technology that extracts data from all kinds of things, right? From Google Docs to Confluence to Slack, Teams, all sorts of tools really, and then a lot of PDFs there as well, images and PDFs and all sorts of things, right? And then I think number two is probably customer service. We hear about this quite a bit, right? So unfortunately, these are some jobs that are being affected tremendously, right? Because LLMs can do a really good job at having decent conversations with humans, right? Software engineering is another horizontal use case that's being monetized. You have GitHub Copilot, Tab9, a bunch of other companies, and it's a real benefit, right? The moment you start using, let's say, Copilot or one of these code assistants, you know the kind of benefits they bring in. I'm sure a lot of you will very well relate to this, right? And of course, we feel that the number 4 horizontal monetizable use case today is actually structured data extraction, which is very interesting, right? You can put LLMs to use right now and actually monetize LLMs that way, right? And I believe that the 5th largest monetizable use case for large language models on a horizontal basis is in sales and marketing, and then we do see a bunch of companies there, right? Now, agents are coming up. Complex systems with multi-agent setups are not really working in production as well as they are supposed to work. And we do have simpler systems working today, but then this is really out in the future, right? I don't think agents are being monetized right now, right? Now, another thing about, data, when you're structuring data, one really important thing to keep in mind is that, hey, when the data is being extracted for a human use case, which is a Q&A kind of a use case, versus structured data extraction where JSON is involved, are two very different things, right? So nothing is stopping a user from uploading unstructured documents to a Copilot, even for example, ChatGPT kind of a system, and asking it a bunch of questions. But the problem is that those answers then remain with the human, right? If those answers are then required in a system, some kind of a backend system, the human then has to copy and paste, or sometimes in the process transcribing data, for example, formats of dates or currencies, things like that. This is not very efficient, and a lot of mistakes can be made. They may copy the wrong field. They may make mistakes while transposing the data. This is not very complete automation, right? But what you can achieve today with large language models and text extraction systems is that you can do machine-to-machine automation, right? So you can take unstructured documents, you can, with text extraction systems and large language models, convert that data to JSON data or a database table format, where you're able to move that data over to the system where it's finally required, right? There is no human in the loop here. Of course, you probably rightly worried about things like OCR errors or things like hallucinations, and those are real things, right? But that's a topic for another day, right? Now, because of this, the ability for us to do machine to machine end to end automation, which is a lot more complete than, let's say, using a co-pilot where a human is involved. You have to, number one, be able to pull data out of mainly PDFs and images and all sorts of things, really, in a very accurate manner, and then use large language models to kind of structure that data, and then so that you can push the data on to either generate SQL or generate JSON, so that you can have an API and pull the data or push the data to systems where it's required, right? This is super useful. And that's the reason why you have a bunch of startups working in this area, where you give a PDF and you can get the raw data out in a manner that large language models can best understand. For example, it's very common to see markdown output from PDFs, right? For tables, for example, right? So that it's very, very common to have very important information in tables in PDFs, and then you give that to a large language model. But how do you represent that table, right? So markdown is one popular way to do that, right? So so this is what we look into in this particular talk, right? So what is the state of the art here, right? There's a lot of challenges around PDFs, and when you deal with tables, and very common to have PDF forms as well, right? So electronic forms that are filled up directly in the browser or in a PDF viewer. And of course, scanned documents are really pesky as well. So you sometimes have decent scans where a flatbed scanner is used, but then other times you have not so decent scans, right? So within double quotes, so these are just smartphone captured pictures of forms and receipts and things like that. And the worst of the worst are really handwritten forms, which are then scanned, right? These can be very, 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 very tough to handle. But the problem is, if you're not able to deal with every kind of file here, there can be a tremendous impact, right? So whenever people switch from automated processes to manual processes, it becomes very, very expensive, and not to mention slow, not to mention error prone as well, right? So you have to have systems that can deal with real world PDF challenges, right? And that's what we look into this particular talk today, right? So why is PDF parsing that hard? Right? So let's take a look at, let's peer into, hey, what a PDF is, and why is it so hard to parse after all, right? Now, PDFs are designed for basically for display purposes and for printing purposes, right? And they are like a device independent format, operating system independent format, so that they can basically preserve the layout of the text. And this is sometimes a good thing and a bad thing, right? The fixed layout thing, right? So there's like a bunch of shapes. There's a screenshot of a PDF being opened in OpenOffice, so you can go ahead and see what's there, what makes up the different elements of the PDF. And you can see like a bunch of shapes here, and there's a text frame and things like that, right? Now, fixed format or a fixed layout is not essentially a bad thing, but it can become bad in cases where you're trying to pull data out of PDFs for to pass them on to large language models, right? So it can become pretty challenging there, especially when, let's say, there's 2-column layout, and then you're reading from one column to the other, whereas you should be reading column to column, things like that, right? So it can be pretty challenging. Humans, it's very easy when we look at a academic content, which is usually multi-column layouts. That you read one column and go to the next. You don't read a line from column to the next column, right? So that's what is the difficulty here. So in reading PDF, so a fixed layout, sometimes good, sometimes bad, right, for our purposes. And take a look at this. This is a scanned PDF, but if you peer into the PDF, this is basically just one shape in there, and that shape contains a single image, which is the actual scanned image, right? So This is not, there is no text, so to speak, right? It's a fairly simple scanned PDF, right? Now, you may also sometimes need to take the page out of the PDF, I mean, page by page out of the PDFs, and then you may have to deal with them, because especially for scanned PDFs, you can have different lighting conditions, you could have rotation, you could have skew, and you could have obstruction, people trying to hold their passport from folding and then taking a picture of it, or holding a driver's license in their hand and then taking a picture, and then a finger maybe basically hiding some information, obstructing some information, right? And of course, compression artifacts, when you have pictures being included in PDFs, you can have compression artifacts, which is fairly common, and it can really mess with the text in there, right? Now, there are what we call as searchable PDFs. This is very, very common. So you can have a PDF which is actually a scan, which is the original scanned image. But then there's PDFs usually have internal OCR, which can have text overlaid on the scan. So you sometimes have PDFs that are really scans, but in a PDF viewer, sometimes you can actually select the text, right? This is possible because of the internal OCR that PDFs sometimes use. But there's a huge difference when it comes to searching for some text versus when you are actually extracting the text, right? And when you programmatically look at such PDFs, you can actually find text. But the problem is you'll have other issues, like if you take a look at the screenshot here, you have learning algorithms, which is in the original image. But then when you have the OCR, there's double spaces between all the letters in this particular term, right? Which will mess with your extraction, right? This is a very, very common problem, by the way, right? And then tables are a huge problem as well. There's all sorts of tables in PDFs, but luckily we do have a bunch of libraries, Camelot, Tabula, PDF Plumber. We look at some of them today. And then, of course, sometimes there's rules-based extraction. Some of these libraries use all kinds of techniques: rules-based extraction, computer vision-based extraction, machine learning based extractions, sometimes hybrid methods. And there's no one easy way to look at a table and say, hey, I need this table. This is fairly a complex operation, unfortunately. And when these tables tend to span different pages, it just adds to the woes that we have as developers trying to pull out information from these PDFs, right? Now, page orientation can be a problem. So you might sometimes need to detect what the slight difference in orientation is and then correct it before you process, right? This is especially a pain when sometimes even badly placed images on flatbed scanners, or especially true with pictures that are clicked using smartphones, right? So this is something that you might need to fix before you can extract text, right? Now, this is again, text rendered as shapes is a fairly common problem. So when you have text in a PDF, in a normal good PDF, right? Text is text. You should be able to extract it easily. But sometimes what happens is that every letter is turned into a shape and then placed in the PDF. This really depends on the PDF generator that you used, right? So in this particular case, you can see that A is or every letter, in fact, is represented as a shape, as a Bezier curve, right? So that's a huge problem, right? Now, with these PDFs, the only way you can extract text is just to do OCR to figure out, hey, what these letters are, what these words are, and then extract them out, right? There's no other way. Now, I touched upon this briefly. Very common with scientific and academic literature is multi-column layouts. So if you have to semantically read this text, you will have to read this column by column. But then when you sometimes extract text, if the PDF is not generated properly, you will read one sentence across columns, right? This is a huge problem because semantically it won't make sense. Then you have to figure out down in the pipeline how you're going to handle such text, right? Now, multi-column layouts, continuing that, it's very common in forms, right? And you can also have watermarks that can further confuse any OCR systems, right? Now, let's look at handwritten forms again. Very common. These are usually just OCR. You will have to use OCR, but then again, not all OCR systems are adept at converting handwritten text to proper ASCII or Unicode characters. This can be a huge problem as well. Like I said, every time you face a problem, you'll have to kind of fall back to manual methods, and that can be a huge pain as well, right? Now, when we deal with PDF forms, checkboxes and radio buttons are very common. For example, in this particular screenshot, you see that citizenship is a radio button, and so if you have to determine that this particular person is indeed a US citizen, then you'll have to, number one, detect checkboxes. You have to render the checkboxes in a manner that large language models can understand, and then you have to do the prompt engineering to kind of pull this particular data out, right? Now, not to mention, many PDF extractors are unable to pull the text out of fields that are filled up by the user, right? So we have seen that PDF.js does a really good job, but unfortunately, many of us work with Python, and then it's a pain. Then you probably have to set up a different service that has PDF.js, and then you'll have to send the document over to PDF.js, the particular service, get that data back, and then process it in Python. But hey, if you use if you're in the JavaScript world, it becomes a little bit easier to use PDF.js, right? Or sometimes you might have to, there's just no other way, you might have to use a third-party service, right? Sometimes that's not possible because of privacy reasons and things like that, right? So now we have seen other challenges. Sometimes very large, huge PDFs that can be hundreds of megabytes that have very high resolution images. We have frequently had problems where we ran out of memory when processing such PDFs on the cloud, right? Those are common problems as well. So you'll have to devise special ways of dealing with them. You have to detect that it could be a problem and then deal with them in a certain manner. And then there's a lot of bugs in low-level text extraction libraries that you will have to deal with. Headers and footers are another headache that you will have to deal with, especially if you don't want to confuse large language models, depending on what exactly you're trying to do. And sometimes we have seen that there's pure text PDFs, but then there's an image in there, for example, a resume, where the highlights are actually an image. There's text inside of that image. So unfortunately, you might have to do text plus OCR kind of a combination, or just run the whole thing through OCR, right? The problem being that OCR is, number one, expensive, number two, may not be very accurate. Sometimes there are corner cases, and also very time consuming, right? So while you can extract text out of PDFs within 50 to 100 milliseconds, when you have to deal with OCR, even a single page can take up to 5 or 6 seconds, right? So that's a huge problem. So if latency is a problem for you, then OCR is going to be a problem for you as well, right? And tables, like I said, spread horizontally across pages is a huge problem as well. And there could be privacy-related issues when it comes to sending PDFs to cloud services. So you may not have the choice of always using a cloud service. That's a big problem because this could be sensitive data, and then you might need either something that you can run on your own, or you have to find a vendor who would allow you to basically run their service on your cloud, right, or on your infrastructure. This is very rare, right? So now, to kind of summarize, right? So there's a bunch of things that you need to do if you are very serious about parsing PDFs. There's a lot of things that you need to achieve. These are some of the top level modules that you might need in any professional PDF parser that can deal with real world PDF data, right? Now, what is the approach that we're going to take in this particular talk, right? We're going to take unstructured documents, and we will use some text extraction service or library, and we're going to test a few of them today as we do live, right? And we will extract raw text, right, which is what we need. And then we will use a combination of Pydantic. The little pyramid logo is actually Pydantic. I should have probably written Pydantic there, but that's Pydantic. And then we will use a combination of Pydantic and LangChain to create structured JSON data, right? This is a very, very common use case. You'll agree, right? Of course, there are other problems with this approach. We'll come to that. So like we said, we will look at simple tables with native text PDFs. We will look at PDF forms that are filled out forms, right? Not empty forms. These are filled out forms by some user. We'll try to extract the whole form, but also the entered data, user entered data. We'll also look at scan documents today, right? We look at some decent scans, probably using one that was generated using a flatbed scanner, right? But then not so decent scans as well, right? Orientation problems and things like that, right? And we'll also look at handwritten forms, which can be really, really pesky to deal with. But hey, it's the real world. So today we're gonna look at really difficult to deal with documents, right? Now, I want to call out that we will look at text extraction and structuring, but we'll keep it really simple, right? No error handling. We'll share the code in a separate email, the code and this presentation, this particular deck. But then when you deal with large language models, you will see other things like hallucinations and just plain wrong extractions and things like that. We will not be covering those in this particular talk. That can be a talk in the future. So we will basically, that's what we will deal with today, right? We will look at libraries like PDF Plumber. We'll look at Camelot, Tabula. We'll try and extract tables using these libraries with some of these real world documents. We'll also look at unstructured IO as a service, not the library, but the cloud service. Then we'll also look at Llama Parse. We will look at LLM Whisperer as well, right? Which is the service that we run, right? Now, so let's look at some sample PDFs that we'll deal with, right? So I have a folder here. So there is there's some examples of clean PDFs. So we will try and extract this table. This is Apple's 10Q document. This is a clean PDF. On page 14, and we will extract.
Can you zoom in a little bit onto the PDF?
Sure.
Thank you.
So this is page 14 of the second quarter 2024 report from Apple. And we have this segment information and geographic data that we will pull out, right? So this is a pretty neat table. We should be able to pull this out, right? So there's only one page we'll deal with in this particular document. This is a fairly large document. This has like 28 pages in it, but we're gonna just extract page 14 and go from there, right? And we will look at this credit card statement. Again, a very common PDF type, especially in financial processes. Credit card statements, bank statements are very common. We are interested in pulling out data from this table, which is the list of spend items, right? So let's concentrate on this. These two are very clean PDFs that you should be able to pull text off right away, right? Then we will deal with forms, right? This is called a 1003 form, which is a loan application. In this particular case, it's filled out. So you have the person's name here, their social security number, date of birth, and then there's radio buttons here, and which we will need to parse if we are interested in figuring out what, like, for example, this person's citizenship is, or individual credit, joint credit. But there's other fields that are filled out which we will need to pull out as well. So marital status is another radio button, and we have things like the state, and we also have checkboxes here, like check if you are the business owner or self-employed. So this checkbox is actually checked, and in fact they are like a 25% or more business owner, and there's some text here, things like that, right? So we'll need to pull all these things out, right? So this is an example of a real world PDF form, this is a very common form as well in BFSI, right? Then we will look at handwritten forms. Again, there are two challenges in this particular PDF, right? One is this is a handwritten form. so that we have the name. And this is not great handwriting, right? This is what real world handwriting looks like. And then, they're not making any efforts to make our lives easy. And so there's again radio buttons here, right? And then there's check boxes here. Again, there's a checkbox here. But to make matters more complicated, on page 2, there's only 2 pages here. On page 2, we have a driver's license scan. Unfortunately, the orientation is completely wrong, right? And we'll have to deal with this, right? This is something we see every day, right? Then we have a smartphone captured PDF, a picture, right? This is just a food receipt on a table, and not very flat. There's some grease on it, maybe from the burger that they ate. And there's 3 columns here very clearly. If you want to consider this a table, if you pass this on to a large language model, it's very important to preserve these columns so that we can ask the large language model, hey, what are the line items here? What is the individual amount and the total quantity, things like that, right? So yeah, so these are some of the real world documents that we will look at, right? Yeah, so to summarize, we look at clean documents, PDF forms that are filled out, handwritten forms, sometimes with additional information like bad scans, and then finally smartphone captured pictures as well, right? Now let's look at how code might look. So I'm going to pull out this PDF again. So as we saw, we're gonna go to page 14, right, where we have the table that we're gonna pull out. But before that, let's see, hey, are we able to pull out this information without problems, right? So with Camelot, we're trying to read the tables and then print it out as a data frame. It's a fairly simple PDF, which is just pulled from the internet, right? There's no complexity in this PDF. But you can see that I'm going to go to the terminal here, and I'm going to pull this up, right? And it's a fairly simple program, right? So we have a let me pull this down again. So we have a fairly simple program. This time it uses Camelot, and then I'm just gonna pass this file name to it, and then I'm gonna see how it works, right? We just gonna run it, right? So we say Python Camelot extract, and then we're gonna say clean, and we're gonna say apple, right? Now what we want to do is that we want to pull out all the tables and text from this, but as you can see, it's not pulled out anything. I think that is the problem. But let's check out with the other file that we have here, which is the credit card file. Should be okay. Right. So it has pulled out one table, and that table seems to be the first one, which is this. But as you can see, it's done a pretty bad job at it, right? So there's hardly anything that makes sense. And then, we do see some of this, but then we don't see like the 15 years, this second column and things like that. It's not doing a really good job, right? Now, let's look at the other extractor, which is PDF Plumber. In this particular case, again, we're just trying to extract the tables from each of those pages, and then we'll see if we succeed in doing that. Right? Now we look at this Python. We'll say PDF Plumber, and we'll also say clean, and then the this particular thing, right? So it's able to do like some tables, like the first one that we saw that Camelot did succeed in pulling out. And then there's another table which is which has something to do with the contact information. like this one. But unfortunately, it's not pulling out the main table we need, which is the spend line items, right? So here lies the challenge with using some of these libraries in open source, right? We'll also look at Tabula. And we'll give it some time. I think this uses a Java backend, if I'm not wrong. So there you go. But then again, we don't find the right. Again, we don't find the right tables to be pulled out, and many of these extracted values are actually not usable at all, right? So these we are seeing that for table extraction, they aren't really all that good, right? Of course, we're going to share all of this code later on along with all the documents with you. An email should follow after this talk, and then we'll take a look at it, right? Now, let's look at some other documents and libraries, right? So let's look at, for example, let's say unstructured, right? So let's look at the food receipt, right, which we have here. Let's take a look at that. So we're using unstructured.io's service. It's not the library. So this document will be sent to the cloud, right? Now, we did get some amount of decent information. Now, we do have the name properly. We do have the address properly. But then there's some junk here. There's some junk here. There's some junk here, right? And things like that. And then there's a lot of confusion around the other items here, right? So the name is mangled and things like that, right? So it's not very bad, but then there's a lot of things like, hey, powered by, and that's got, mangled up somehow. We got the name of the company here, but then powered by later on and things like that. It's basically struggling, right? So there's a lot of spelling errors and a lot of mistakes here. But let's try, let's say, a llama parse, right? And let's try this time. Let's try the scanned loan application. Let me bring that up for reference, which is the handwritten loan application. Let's try this and see how that works. Again, this is a cloud service, so the document will be sent to Llama Parse Cloud. This can take awesome. So we do have some markdown tables and things like that, but unfortunately, we don't have a lot. For example, you have the borrower information here, right? And then you have the name of the person. Unfortunately, it's left out the first name. The last name it did pick up, right? Which is a bit of a problem here for us, right? And the social security number as well is not very cleanly picked out. As you can see here, there's 12 digits here, but then there's a bunch of digits missing and things like that. And the other problem is that it's not picking up the checkboxes and radio buttons like we want. So we have no idea. For example, married is checked here, but we don't know whether it's in the text. We'd have no indication of that, right? Now, yeah, this is a bit of a problem for us, right? Now, I could go through every combination of using a service on a particular type of file, but unfortunately, we don't have time for all of that because I want to cover a few more things, right? So I want to be able to extract some of this text and then put it through a large language model and actually say, hey, If this person is a US citizen, it should tell us it's a US citizen. If this person is married, it needs to tell us that, right? We need to do all of that, but we need to first of all pull all this information out properly, right? Now, I want to show you how we deal with this kind of stuff in LLM Whisperer, which I'll just show you two different things, right? So we'll use LLM Whisperer, right, with the same document, but this time I want to show you how, for example, we deal with checkboxes and radio buttons, and also handwritten text, but also this scan, right? If you look at the previous output from Llama Parse, the license, the driver's license, is completely ignored because it's not able to figure out how to deal with it, right? So, but we'll see what LLM Whisperer does. Here's the output. If you look at the output, we have the handwritten text perfectly pulled out. So here's the first name, here's the last name, here's the 12-digit social security number, and the radio buttons are actually rendered like how humans would render it, and large language models can actually figure out quite a bit from this. And I want to bring to your notice how it preserves the layout of the document. So in this case, there's 3 columns here. And if you want to pull out citizenship, this has to be on its own column. Otherwise, large language models wouldn't be able to figure it out, right? And then things like, I'm applying for individual credit. This checkbox is rendered properly. And then we have marital status, which is rendered properly as well. Phone number, all those things, again, right? And also there's a lot of things that are filled out here. The name of the business and the address and things like that, in not such great handwriting, but we do have everything pulled out properly, right? So that's great. But what happened to the driver's license, which had a wrong orientation, right? Turns out this is the next new page marker, and we do have the California, USA driver's license, and all the details pulled out properly. We should have absolutely no problem pulling this information out using a large language model, right? Awesome. So let's go ahead and look at one more example, probably, right? Say the smartphone cam, the food receipt photo, right? Now, like I said, we need these 3 columns to be maintained properly in order for any large language model to figure this out. That's super important. So let's look at a couple of examples. Let's try. Llama Parse actually has very decent, OCR abilities. So let's look at how Llama Parse is able to do it. So we want this smartphone, the food receipt, right? It's very important for the layout to be maintained. That's really the important thing. So let's see whether that works, right? There you go. We have actually pretty good output from Llama Parse. They done a pretty decent job, right? So here's like a heading. So they have this hashtag here, and then the address is pretty decent. There's no layout preservation going on here, and that can be a bit of a problem. And but the problem is that the line items, this table is not maintained, right? So you do have Jack the Ripper, and then you have 400. Unfortunately, the quantity is not picked up as a separate column in the table. So it's missed the quantity for all the different line items, right? And so that's a problem here, because we're not going to be able to properly process this if we need the quantity properly, right? So in fact, for the first row, it just thinks that there's just 2 columns, whereas there is 3 columns here, and it did figure out that there's 3 columns in the second and third row, but then it missed the quantity here, right? No problem there. Let's figure it out. So we will try the same with LLM Whisperer. let's try this PDF. Again, this is being, you can see some of the parameters. Again, the good thing is that all three cloud services, by which I mean Llama Parse, Unstructured.io, and LLM Whisperer, they all have Python clients available, right? Now, here's the important thing about LLM Whisperer is how much trouble it goes through to maintain the exact layout of the input document, right? And you can see that it's pulled out all the text, and then it's inserted spaces so that you know that, hey, there's a different columns here, right? Now we should be able to send this to a large language model and get pretty decent output, right? So good job with these kind of documents, right? So awesome. So let's summarize. Of course, we haven't run all of these libraries through all of these different documents. We don't have time for that, but hey, that's like an exercise left for the user. And then let's summarize so that, hey, we can move on with the rest of the talk, right? Now, so this is the comparison. We did not have, unfortunately, really good luck with Camelot, PDF Llama, and Tabula. So we did not proceed with forms and handwritten text and the smartphone photo. But then we did see that with clean text, we are getting good output for both Unstructured.io and for Llama Parse. But then when it came to forms, we didn't see like proper data being pulled out. Handwritten text and photos, fared poorly, right? Now, Llama Parse, I think, is an improvement over Unstructured.io. There's quite a decent version of OCR in there and things like that. But when it came to handwritten text or forms or photos, we did see really, really good output with LLM Whisperer, right? But what are we going to do with that output, right? That's the important thing, right? Now, for the final bit of the talk, what I'm going to do is that we look at how do we structure this data. Now, you got raw output from these PDFs, right? So a really good way to structure this data is to use something like Pydantic and LangChain, and give it the raw text pulled out from these PDFs, and then create structured JSON data. We'll see some exercise of in that area, right? Now, first is the way this works is I just wanted to kind of give you a overview of how this works conceptually, so that when we look at the code, it actually makes sense, right? Now we have a Pydantic class definition of the schema. So think of this like a simple structure, like a C++ structure or class or whatever, in which we say, hey, we need the name, the date of birth, this is the type, the name is a string, the date of birth is a date, things like that, right? So we define the schema, right, which will really become our JSON schema finally, right? And then there's this method called get format instructions. Now, as you define, I'm going to jump a little bit ahead. This is how a class definition looks like. So you do provide a description of each field, and the great thing is that get format instruction, this particular function, can actually take that description and create a prompt for you, so that hey, you get the right type and you pull out the right information from the raw data, right? So we have a system prompt first. We call this a preamble. Then we have the format instructions which are generated from the Pydantic class definitions that we create. Then we insert the raw file content as extracted by LLM Whisperer. Then we have what we call as a postamble, which is just, hey, how we finish this, right? Then this becomes the final prompt. We take all of this and then from a template and then create the final prompt. We send the final prompt over to a large language model, and hopefully we should have structured JSON back, right? Now, if you look at Pydantic, it's a fantastic library, right? So first is we have this class for credit card. We want to pull out credit card spend line items, right? So we have this class called credit card spend items, but we have a list of this class, right? But then we also describe this list of spend items from the credit card statement. Then this is a single spend line item, one line item, right? Which has the spend date, the merchant name, and the amount spent, right? As simple as that, right? That's all we need to do in Pydantic, right? We take this and this looks complex, but it's actually pretty simple. We saw this where we have the preamble format instructions. This is exactly what it is, right? So we have the preamble comes in the as a parameter because we're sending it from here. This is the preamble, right? Then we take the postamble. We create the system template from the preamble, right? We create the template from it. Then look at the human template, right? We have the format instructions, which will be generated from the Pydantic class definition. This function does that, right? And then you can see how we do that, right? There's a preamble, then the format instructions generated from the Pydantic class definitions, then the extracted text from LLM Whisperer or whichever library you use, then the postamble. Then we just create a huge prompt from it and then send it over, to the large language model with a temperature of 0 because we don't want any creativity here. We just want the data plain and simple, as simple as that, right? So let's look at the code. We will see this in action. I do have a couple of, the table extraction is here. Again, we will be extracting 2 different tables. We will extract the line items from the credit card statement, but we will also extract this particular table, which is, by geographies, whatever, the 6-month income was. And now we're gonna run this, right? And we should have the output here. Again, this code will be made available. There you go. So take a look at what LLM Whisperer has done with the it's maintained the column so that it becomes easy for the large language model to figure out what this is, right? And now the data has gone to a large language model to create a JSON. From this we have the output. So if you look at the JSON now, we have the spend items, which is the top class we defined, and there's a list of spend items inside the class. So we have the individual items here, which is awesome. Then we have the Apple, the 10Q document, which is this extraction. So this table is extracted beautifully like this, right? And from this, we have for the Americas, quarter ending, this 3-month, 6-month, both Europe, Greater China, and Japan, right? Rest of Asia Pacific. Beautiful. So we have the output as we need. So this is the first example. Next is we look at the checkbox processing, which was here in this particular example. If I can refresh your memory. Now we need to answer a bunch of questions. Here we are looking at personal details, extra details, current address, employment details, and things like that. The base class for this is form 1003, right? So we're gonna run this. First, let's look at how the form is actually extracted, right? So what does this form become, right? So we do have an extraction, which is good. We have a rendering of all the checkboxes and radio buttons properly. And we have the details in JSON beautifully extracted. Personal details, SSN, date of birth, right? And then here's the thing, right? To figure out citizenship, the large language model use this output here, this column. And it's able to figure out that, hey, this is checkbox and US citizen is checked. And same for marital status, right? So married, we got that information through that checkbox, right? So it says, hey, it's married individual. Again, we have some more complex, prompts to pull out this, but then all the magic is pretty much there in these descriptions, right? And we are able to do that, right? And we have only 5 minutes more, but we do have time to look at the handwritten PDF extraction, which was actually a pretty challenging one, right? So there's a scanned loan application which has a driver's license, and it also has a bunch of things. It is pretty much the same as the previous example, except that now we have an extra driver's license. But unfortunately, all of this text is handwritten, right? But let's see how we do. I'm gonna run this. Hopefully, we should have a decent extraction of this handwritten text, which we saw already is actually pretty good, right? It hardly missed anything. And from there, even though some of the check boxes are actually by hand, they're checked by hand, but we do have the driver's license here, and we have the even though these check boxes or radio buttons were hand checked, we do have everything properly rendered here. And from this, we should be able to extract pretty much everything, including the driver's license details, right? So that brings us to the end of the presentation. But I'll see if we have any questions we can take, and then we'll go from there. I did have a slide. So I mean, these are some coordinates, right? This is the company website, and then there's the open source Unstruct project, which allows you to structure data. Please give us a star on GitHub, and you can find me in a bunch of different places, or email me to follow up, things like that. Happy to answer any questions you might have.
Cool. Thank you, Shuveb. That was really well done. Very dense, a lot of information to pack into an hour. I think we've got a couple of questions in the chat that you can look at answering. So Vignesh asks, yes, how to use a custom prompt as done in this webinar to compare function calling for the same purposes.
No, that's awesome. That's a great question, right? So function calling, super useful in a variety of situations, no doubt about that. But these are fairly simple extractions, right? You don't have to call a function to achieve this level of extraction. So when it gets a little bit specialized, or you need speed, right? You definitely can resort to function calling, no doubt about that. Yeah. And especially when it comes to arithmetic, large language models are pretty bad. And so function calling in those areas, or you want to access a database and things like that, can be pretty useful.
Cool. He also asks, should open source models be fine-tuned to understand things like checkboxes specific to services like LLM Whisperer, or would the pre-training tokens be sufficient to recognize things like this?
No, the checkbox itself is fairly simple, right? So you simply just a square bracket and then X inside of it. We have seen that open source models do perform pretty well with this. There's absolutely no need for fine tuning here.
Very cool. Nikita asks, what about extracting information from research papers? Should important information for training the model with information be extracted manually and then train the model, or can we upload the paper?
So look, here in this talk, we mainly covered the extraction bit, right? So it's a completely different wheelhouse where there's vector databases involved and all sorts of things. Your mileage will vary when tables are involved and in a very large document, right? So vector databases aren't really good at, like, if you use a very simple scheme of just getting the top 3 or whatever and then sending to a model, your mileage will vary, but you have to use smarter ways of retrieval to achieve accuracy if the document becomes larger. But yeah, like I said, the extraction bit is very important for large language models because garbage in, garbage out, and that's a very important bit, right? So tables rendered properly, luckily for academic papers, not such a big deal, right? Because you will have typically clean PDFs. So yeah. So but anyway, the RAG bit is another story altogether.
Cool. And I don't know if you have the context to answer this question, but someone asks, is Llama parse configured to use Sonnet 3.5 or GPT 4.0?
None. We just use a llama parse alone. In this particular case, we did not use a large language model. We simply use the llama parse service to extract text only, not ask questions later on.
Okay, cool. Yeah, I was like, I don't think Llama parse uses either of these, but maybe I didn't know something. So, okay, cool. That wraps up our time here. Thank you very much, Suvaid. And we'll see everyone next week.
Thank you so much, Yuja. Take care, folks.